Hello, everyone. My name is John Goss. I'm former president of the Astronomical League. We're having these sessions throughout the year to help celebrate the League's 75th anniversary, which was on November 15th, 1946. Today, we have with us this Steve Boerner, who is a member at large of the Astronomical League, and he's here today to talk to us about the radio astronomy observing program that the League offers. Steve is the coordinator for this program, and so he knows all about the details of it, what it takes to get it done, what's involved, how to do it, where to submit your observations, and so on. This program was originally started, I don't know, about 5 years ago by Astronomical League vice president at the time, Bill Bogardus, and he went to Green Bank, West Virginia, a number of times and saw the radio telescope facilities there, and started wondering if he could, or if the league could have some program for amateurs. So he contacted a number of amateur radio astronomers and talked to them how to get something like that going, and he got it developed and got it passed. And so the league's been offering this for a number of years. So Steve's been gracious enough to take this over after, unfortunately, Bill Bogardus passed away a couple of years ago. So I'd like to turn this over to Steve, and he can tell us all about the program, how to do it, and how to have it. The number one thing is to have fun doing it. So he's going to tell us about how to have fun doing this. So Steve, you have something to say?
Okay. Well, first off, I'm going to share up the screen, and it is that one, I believe. And hopefully John can see that.
Yes.
And I'll tell you that I'm here to talk about the Radio Astronomy Observing Program. And I have this shared up on the internet, and I'll keep it up. And so if you would go to this URL, it's a tiny URL, Radio Astro, you should be able to do it. Bill Bogardus, as he mentioned, was the person who wrote the program, and I'm a coordinator, and obviously that's today's date. These are the two pins down here. And then John has already mentioned Green Bank. This is a picture down here of the barn and the big radio telescope at Green Bank. And ultimately, the big radio telescope is kind of important because its picture is on the certificates for the program. I'm going to go ahead and scroll through and just kind of talk. If you need to find information about the program, you can go to the Astronomical League's webpage, and this is the directions here about how to find the radio astronomy program's requirements, or you can just go ahead and click on that link, and that link right there would take you to the Astronomical League webpage, where you would be able to see the requirements in detail. I'm going to try to go over some of the requirements with ideas and hints and suggestions, but you will definitely need to look at this right here to be able to see what's really going on. If you look at the Astronomical League's radio astronomy program, there are 5 different parts. There are 5 different kind of observings that you're going to do. One deals with something that's called space weather. It's something that's called SID. You can see that there. You'll be observing the sun with an itty bitty radio telescope. Actually, you can see and hear some things from Jupiter. You can detect meteors even during the daytime with the radio. And then you are going to be able to look at galactic kinds of things. Technically, when Bill wrote the program, he only said galactic. I've managed to add the whole idea of extragalactic. So that's really the only change that I've made since I've been the coordinator. I will tell you that you do need to do some construction as part of this program. Some of the things that you would use, you can buy already made. In other cases, you have to assemble the parts, make antennas and that sort of thing. And definitely Google's going to be your friend. Search these 5 different categories up here, these 5 different classes of things, and you're going to get all sorts of information on the internet on those. Okay. If you look at the program, there are 3 different levels. There's what I'll call a beginning level, which is the bronze level. And technically, anybody in the world can do it. You don't have to be an Astronomical League member. You can do groups of up to 3 people. You know, everybody's got to help do it. Everybody's got to understand it. But at least you can have other help getting it. You don't have to do it by yourself. And the reward, if that's the right word, the recognition for the program is an electronic email certificate. You will get it that way. The silver level is the next level. You do a second one of those 5 areas up above, and in that case, you'll get a pin and you'll get a certificate. And then for the gold is the final level. There you do an additional 2. So a total of 4 out of those 5 areas, okay? For the gold, you get a different pin, you get a different certificate. And when you do the gold, you do have to do the galactic, extragalactic portion of that program. I will tell you that, again, you need to go to the web page and it'll tell you the specific requirements. It'll tell you, like in some cases, timing, where it has to be done over a certain number of days or something like that. I want to now look at those different kind of areas and talk about them. The first area is space weather, and that deals with sudden ionospheric disturbances called SIDS. And you can see here, as you would read through the page here, that bottom line is that when the sun is active, it'll give off flares, solar storms, CMEs, and the radiation, the particles from that will interact with the Earth's ionosphere. It'll cause the ionosphere to change. And what you do is you try to detect those changes via a radio. To do it, you're using a very low frequency band, and very low frequencies are literally well below the AM band. They can be below 50 kilohertz. They're really, really, really low. So it takes a special kind of radio to be able to detect them. When you do that, you have an option. You can make your own equipment. There are, have on the next slide, some information about where you can go to do that, or there's actually a ready-made solution for that. And you have a choice of whichever you would like to do. Bottom line is that you're going to be looking at signal strengths on very low frequency beacons, and they're going to be in the range of 15 kilohertz, 30 kilohertz, and which ones you use are going to be very dependent upon your location wherever you are in the world. It's kind of interesting. You'll notice here where it says secure military communications. Some of those beacons are actually used to communicate with submarines while the submarines are still underwater somewhere on our planet. So that's the kind of thing you're going to look at. To do it, you need, I'm going to call it the special radio. It's not a radio that you would use to listen to a baseball game or a football game or anything like that. It's a special radio designed to pick up the signal from those various beacons. Couple of places to go. One is something that's called SARA, the Society of Radio Amateur Astronomers. And I have right here the SARA, whoops, wrong one, the SARA website. And that link takes you to that SARA website, and it will tell you how to order this little device right here, which is called the SuperSID unit. And the SuperSID unit is done in cooperation between SARA and Stanford University. You can see it down here, SuperSID Center. And that radio assembled already and working, probably working, is going to cost you about $60. You can try to make that sort of thing, but ultimately you may have some problems getting parts and putting it together. A second thing you're going to need is a special antenna that's sensitive to that area of the electromagnetic spectrum. And to do it, the easiest way to do it is just make a giant magnetic loop antenna. It takes about 30 turns of copper wire on a 1 meter square. The one downside about doing this whole thing is you do need to hook this up to a computer for the computer to monitor what's going on, okay? And so ultimately you need to tie up your computer 24/7 until you're done with the project. This software would like to be able to collect your data for an entire day. And so if you turn it off during the daytime, you'll lose that day. So, you know, you do need to dedicate a computer. If you do buy the SuperSID unit itself from SARA, you run it and you'll get a screen that looks like this. I will tell you that currently, I don't know if this is going to pop up or not. Does John see that? Or is that the same screen? We won't do that. Sorry, you need to edit that out. That was my screen running, and I don't want to try to reshare that. But as you run the software, you'll see a screen that looks like this. And down here is like 0 kilohertz. And up here goes to 50 kilohertz. And what you see are these big, tall peaks. And these big, tall peaks are the signals from the beacons. And the software monitors these beacons, and it looks for changes in intensity. And every 5 seconds or so, it'll store that information. It'll run for 24 hours, and it'll run for 24 hours, and on and on and on. And eventually, when you plot it, you'll see something like this. Over here is nighttime, and it's all junk. Over here is daytime, and you notice after sunrise, it dips a little bit. It goes up in a nice kind of smooth area, goes down at the end of the afternoon, and then goes up, and it goes back to night again. This is a normal day kind of run. if there would happen to be some kind of solar activity that would change the atmosphere, you would see a giant peak. And this happens to represent an M1.2 event that happened back in 2015 that I recorded. These are the things you're looking for. Now, here's the bad news. These don't happen very often. So you might have to wait quite a while to see results, particularly since we're now in a solar minimum. I will tell you, when I worked on the program and completed the program, I finally gave up trying to do it at home. I put all my equipment in a club's observatory 25 miles away from here. I let it run for 2 months. I went back and I looked at the data, and then I said, oh, look, on this day, here's this. So if you try to do this at home and you think, oh, well, this is only going to take a couple of days to do, not going to work that way, okay? I will tell you that as you're collecting data, noise is the enemy, particularly if you got a microwave oven. Some of the software auto scales. And so as it normally is supposed to go, it'll say, look, here's this big peak, and it makes that big, pretty peak like you saw in the last frame. But a microwave is Mount Everest, and it overshadows that. And so sometimes you can't see it if the microwave. So you may need to mask it somehow. The software you get for the SuperSID window is Windows-based, but there is a Linux version. I'm trying to get Linux working right now. It does need I'm going to call it a special 96K sound card. Most computers don't come with that, so you might have to add that on. And there is a Groups.io group that is called SuperSID. And if you want to work on this program, I would really recommend that you join that group. You can get lots and lots and lots of help there. SuperSID. It's cool. It's fun. The second part is called an itty bitty telescope. And here's a picture of an itty bitty telescope. And you think, oh, that's a direct TV dish. And yes, it is. And it's actually, I'm going to call it for the most part, an unmodified direct TV dish because it needs to be adjustable so you can tune it around to different parts of the sky. You'll find out that there's a lazy Susan here. Okay. And in addition, there's a preamp. And then down here is like a satellite detector. Something that you would use to normally take your direct TV dish and find a satellite. You need one of those. It's a starter instrument. And generally, what you're going to be able to do is you're going to be able to use it to be able to find the sun. And literally, if it's not pointed at the sun, it's quiet. If it's pointed at the sun, that satellite finder down here makes a giant squawk, and you know you're on the sun. Technically, you could use it to monitor the sun, but you'd have to track. And this thing is not a tracking. The dish itself picks up a 12 gigahertz signal and then converts it to 1 gigahertz. And ultimately, the easiest way for me to tell you about this is to look for YouTube videos. It'll show the operation. And then if you also would Google it, you'll see directions about how to make it. You need the satellite dish. If you've got one, this is a workable deal. But if you don't have a satellite dish, I wouldn't. I think the new ones are about $75. I'm not sure I would tell you to go buy one to work on this part of the program. One positive about it, and I apologize for covering up down here, is that if you are a club, if your club does daytime outreach activities, this is a good thing to take along with you to show the sun, because it will detect the sun through heavy clouds. So, it's like, it's raining. What can we do? Well, take this and have the kids find the sun. So that's one positive about that. The third area is observing Jupiter. And it turns out there is a project called Radio Jove. I'll talk about that in a second. But bottom line is when when the satellite Io is in a certain position relative to the Earth and Jupiter, there is electromagnetic radiation that comes off. And you can pick it up in the shortwave range, somewhere between 4 to 39 megahertz. You need a directional antenna. This happens to be a lot of this in the normal shortwave radio kind of range. And the only really problem is trying to find out when those events occur. I mean, obviously you can point your antenna at Jupiter and hope, and so if you go in advance knowing that, oh, it's supposed to happen between 8 o'clock and 9 o'clock tonight, you have a higher level of success. 20 megahertz is usually pretty good, not exactly 20.1 or something like that. You can pick stuff up. And then there are two kinds of signals that you will get. And I think I have up here's one of them. And it sounds like popcorn. So you're listening for a signal like that. Or here's a different one. And it sounds like surf, waves, ocean. And those are the kind of noises that you would expect to hear on your shortwave radio if you're picking up these kind of emissions. And let me stop this guy and go back to that. And here, down here, these two links take you to those. Now, how you get this done? Two different ways. There's a commercial solution, and the commercial solution is, I'm sorry, I'm pulling down stuff here that I don't want to pull down up at the top. No, get away. There. One is called Radio Jove, okay? And at Radio Jove over here, you can order a kit. The kit is about $210, and in that kit, you will get the parts that you have to assemble, okay? And assembling the parts would be good for somebody who's really good at soldering and that sort of thing. But if you're not that kind of person, the other way of doing it is putting together things that make use of something that's called a software-defined radio. And here's a picture of one over here. These guys are about $30, and these actually are, believe it or not, shortwave radios, okay? And you can use one of these things, and it plugs into your computer. Up at the top, here's a little USB port, and then you route on the other end the thing to in your antenna, and then using a piece of software called SDR Sharp, you can, you can detect these things if you have an antenna. The Radio Jove project recommends using something that's called an element phase dipole antenna array. I've seen somebody put one of these up at a Green Bank StarQuest. They take quite a while to do, and they take a pretty good size area. I'm going to say maybe 20 feet by 20 feet, okay? And so unless you're dedicated and have help, that's kind of hard to do. I have tried to do it with a dipole antenna. A dipole antenna that I used, I think was, and I don't remember at this point, 25 feet long on the side. They work, sort of. If you go to the internet and search, you can also find somebody who's used like a little plastic table. They don't work. Don't try those. Try to avoid them. Down at the bottom, I have a link, and the link is to a page that had a article that was in Sky and Telescope, and it takes you to this page right here. Project to detect radio emissions from Jupiter. I highly recommend reading that article. It does a really good job of explaining how it all works, the things behind it. I apologize for a fast scroll here. And then finally, by the time you get down to the bottom of the page, there is a program that's a basic program, basic language program. And if you run this program and get it running and enter the correct dates, it will tell you, oh, look at between 9 and 11 o'clock on April 15th, and you should be able to hear those. So the program will tell you the possible times where you should try to tune in. And so this is a very, very valuable thing. I will go back and say that if you go for the commercial solution up here, the commercial solution does include a CD, and the CD has a program that's better than the one down at the bottom of the page, okay? And so there's an advantage of going there. But on the other hand, $200 it's a pretty good investment. So I'm not sure I necessarily will tell everybody to go there. The fourth area of the program is personally my favorite, and it's detecting meteors via radio. And I first encountered this in an article in Sky and Telescope, maybe back in 1978 or something like that, and had always wanted to try it. When the program came up, I said, I got to do it. I think everybody knows that meteors produce an ionization trail, and radio waves can bounce off that trail and be detected. How does it all work? Well, over here, we got a transmitter. Think of this as a radio station. And over here, you're sitting and you got a radio. And for some reason, you are either beneath the Earth's curvature, or this guy's not broadcasting with enough power such that the signal can make it all the way over to you. When a meteor comes in and tracks in and ionizes the sky, the signal from the transmitter would bounce off the meteor trail and be reflected over here to you, okay? Since this is too far away, normally you're not going to hear anything, but when the meteor comes in, it bounces off, you can now hear it. And depending upon how you're listening, it can either be, if it's an FM station, you can hear the music playing all of a sudden from the station you normally can't hear. Or if you've got one of those SDRs hooked up to do it, you might hear static, but somehow you detect it, you hear it, you can track it, you can find it. Okay. When you do, you can either see the trails, all the circles represent meteors, I can't remember. Zooverse, is that it? Where you do the program kind of things? They have an activity there where you can do this and say, oh, here's a meteor, here's a meteor, here's a meteor. Or you can hear them. And if I say hear them, here would be an example of something I collected. And there's a little ping, and I'm going to stop this thing and say, right here was a meteor that was just detected. You can see that little bitty white line right there. It said, oh, there was a meteor. I'll play that again. And what you're listening for is the ping. And ultimately, each ping would lead to one of those traces that you see here. And so here, count them all, and each one showed up. Uh, when you observe meteors, it works great with frequencies between about 40 megahertz up to about 140 megahertz. Lower frequencies give better results. The lower the frequencies, there's a math formula involved. It deals with the frequency cubed. So lower frequencies are better. The hardest part's to find a station to monitor. It's got to be something that's beyond what you'd normally be able to hear, see, okay? And you need to use a directional antenna to get that done. And in the United States, FM radio might work, or analog TV channels in the range of 2 to 6. Now, here's the problem. There are not many analog TV channels anymore. At one time, that's all there was, but everybody's pretty much gone to digital today. And so trying to find a station in the FM band or trying to find a TV channel to listen to, kind of difficult. FM needs a gap. Imagine that you're trying to, let's pretend you live in Cleveland, okay? And let's pretend you decide that you're going to use a signal in Detroit, okay? Well, it's going to work great, but if you tune to a channel and there are stations of that same channel between you and it, it's not going to work. You need clear channels, something that you can't pick up, but you're not going to pick up anything else either. So there's got to be a gap. I'll show you that in a second. And then if you do an internet search, it'll talk about something that's called the Graves Network, and it'll sound like it's really, really wonderful. But the Graves Network is in France, and ultimately it's too far to get the job done. So ignore that. Okay, now when you observe meteors, this will give you an idea of what you expect to see. And it's a radio station, not a radio station, it's a website run by a guy who lives in the Washington, D.C. area. And ultimately, it's live. Oops, there you go. And if you watch this, oh, here, see this down here at the bottom, that little peak right there? That said that probably there might have been a meteor at that particular point in time. Do realize meteors can happen during the daylight. If you would like, you can listen to this a whole lot, and eventually you'll see peaks like that, and you'll see the tracks up here. He does explain how all this works, and the truth is that if you are in the eastern part of the United States, I'll say definitely Virginia North, maybe what he's doing would work for you. And he does describe that over here about how he does it, how he's got set up, what frequency he's listening to, and all that sort of stuff. If you want to do FM and try to use an FM signal, there's got to be a gap, okay? If you go to this website, it will draw, based on your zip code, pictures like this. I live in the St. Louis area. This is St. Louis. And I will tell you, St. Louis has no gaps that are big enough for this to work. This happens to be Green Bank, West Virginia. Pick a frequency. If you would tune to this and find somebody at 90 mega, oh, that's 98 megahertz, and point your antenna at this guy, it would probably work great, okay? If you want to do it for TV stations, there is right here, this URL, which takes you to a page that's called Radio Observing for the American Meteor Society. This is good reading. It tells you how to do it. It tells you how it works. And then I'm going to scroll down to the bottom quickly. And down here at the bottom, it tells you in various parts of the country what TV channels might work and where those locations are. So that might be a possibility. I'm in St. Louis, and I know that I've used this North Platte before and the Rapid City before. Obviously, North Platte and Rapid City are not the same, but from where I live, it turns out the antenna pointed at those same results. I get them both at the same time. Okay. The last and final part of the program is the one that's required. It's the one you have to do. And in some ways, it can be either the easiest or it can be the hardest, depending upon what you're willing to try. Obviously, there are all sorts of radio sources in our galaxy. Uh, the problem is some can't be picked up with little bitty radio telescopes, the size of like one of those, let's say, itty bitty telescopes, versus if you got access to a big one, the world is there for you. You may, in doing this part, use your own telescope that you make, or you might be able to find one on the internet that gives you access to it. And down here, it says you got to do your own observation. So if you're doing this with somebody, you can't jump on their back. You have to physically connect the buttons. You have, and that sort of, you got to get your own information. When you talk about the galactic sources, you can build your own. And if you do, most of the time, people do it with a horn-based antenna. And then they kind of put this together on some kind of mount that can tip up and tip down. They point it due north-south and use it in a transit mode. They take the output and they would route it to one of those SDR dongles that I showed you earlier, and they would try to probably use this to pick up a signal at 1440 megahertz. Did it come out right? Yeah, megahertz. A second way to do it, and John knows about this one, is to go to Green Bank, West Virginia. There is a star party there that John and I met at. We've seen each other and that sort of stuff a number of times there. And at Green Bank, they have training in the use of the 40-foot radio telescope. Here's a picture of the 40-foot radio telescope down at the bottom. And they give you time at night. If you want to walk down at, 10 o'clock at night, you can use the thing all night long. And so you can collect your own data. Now, Green Bank will work great if you live in Virginia, if you live in Ohio, if you live in Maryland. I live in St. Louis. I go to Green Bank. That's a long day's drive. Obviously, if you're in the West, what are you going to do? Try to get a hold of Green Bank, and they may be able to set you up with something that's called a Radio Skynet account. And that makes use of a different dish at West Virginia. I know some people have used that. In, I believe, California, they have something that's called the Goldstone Apple Valley Radio Telescope. If you Google that, they do talk about a possibility of training and remote use. So you got a choice. You can try to make your own, okay? Or you can try to get a hold of somebody who will let you use a bigger radio telescope. Here, you're probably going to scan, if you make your own, just the Milky Way and see what kind of signal you get as the Milky Way itself transits. Down here, if you go to Green Bank or you do the Goldstone thing, you probably would have the ability to go for individual sources, to be able to say, I want to look for something out there, a wave, and say, and at this point, I think I've covered everything and talked about everything I should have. And I'll say, anybody got any questions?
Yes.
Answer.
Yes, I do. I have I don't know if they're really questions. There's some comments. I know with the Radio Jove, that has the Radio Jove antenna that has proven popular at some club events, and especially if a club is having a session in which they are observing Jupiter and its moons, Io, and they have the Radio Jove program playing along with it. So there you have kids, for instance, at a telescope looking at Jupiter with Io, Ganymede, and the rest. And with in the background, you'd have the Radio Jove picking up the emissions as Io goes through the magnetic field. It's both a hearing and visual thing in which you're connecting the two activities. Most people, when they see Io, it's that's what you see. But in this case, it's reinforced by the actual hearing it go through the magnetic field, which can generate a lot of enthusiasm. It's something new, something completely different to do. I had a question. Perhaps you can answer it. You mentioned about the picking up coronal mass ejections. A couple of weeks ago, we had a talk similar to this, but on aurora. Can radio astronomy be used for picking up aurora, or is that something out of bounds, way out?
I don't know that is what I've covered here and talked about it, that it would work. I do believe somewhere in the past I've read that it's a possibility that you might be able to get something, but I'm going to defer and say, I don't know.
Well, let's say you can. I think that would be really cool. That would add another dimension to the whole experience. Of course, you'd have to have all the gear with you um, as you head north to see this, but I think it'd be pretty cool. We have another guest here, Maynard Pittendray, who's the executive secretary of the Astronomical. Yes, hello, Maynard. Thank you for joining us. I know he is swamped, as a lot of other people are, with the number of Zoom calls as well as the duties of daily life. So I appreciate you joining us, Maynard, in this last few minutes of the talk here.
Well, it's like some people say, better late than never, except in the handbell choir. So I don't know. You got to be a musician to get the humor of that.
Okay.
And I apologize for being late, but this is an exciting program. I'm looking forward to seeing the posting of this on YouTube. And I thought I could catch a little bit more of this than I was able to. But
You know, I like to emphasize about some aspects of this program. Steve talked about all the equipment. You know, all this is something a lot of people have never heard of. And have no idea, and they think of stores like Radio Shack, which isn't there anymore, or other things. I got to do all this stuff, and yes, it does take some assembly and some research to do it. And if you're a hands-on type person, it's probably right up your alley. And and don't get turned off by some of these prices. You know, Steve was talking about the $200 telescope and all this. Well, yeah, but you know there are workarounds, and some of this stuff really isn't very expensive. Yes, Maynard.
I will say this, that I am not the kind of person who finds this easy, but I've done the Jove telescope and I've done the itty bitty telescope. I didn't cost me much at all. I waited for a neighbor to throw out a television satellite dish on the road and picked it up. And when I was constructing the electrical work involved with the itty bitty telescope, I actually went to Radio Shack. There's one left here in Orlando. We got everything here. And the thing is, the fellow sat down, he asked me, what in the world are you doing with this? And I told him, he said, well, bring in the stuff and I'll make sure you're doing everything right, putting it together. So you have to do your own stuff, but having someone over your shoulder says, no, don't do that, is a helpful thing.
Yeah.
I was really lucky when it came to the itty bitty telescope. I went to my first star quest at Green Bank, and I had no idea what was going to go on, other than the fact I wanted to be out of St. Louis and I wanted to be somewhere different. And I'd been to Green Bank before, and I knew that I could get a tour and go up to, the 432 feet on the GBT. And when I looked at the schedule, the first year I was there, they had a session done one afternoon where a guy from Sarah said, give me a $50 check and we'll build you an itty bitty telescope. And he had all the parts to make 8 or 10 of them. And I ponied up and boom. And turns out I met Brian Tobias, and we were both screwing things together and handing back and forth tools and that sort of stuff. And so that's how I got my itty bitty telescope.
Yeah.
And then at the very same Green Bank thing, there was the guy who did a presentation on Radio Jove, and we put up the antenna, and that's how I saw it done. And I kind of decided that I couldn't put up that antenna by myself, and there's no way I was going to solder that thing. So I know that when I did the radio astronomy program, the Radio Jove part was the part that I didn't do, because you only had to do 4 parts. And I've gone back and done it, but still.
Yeah, I think looking back, I wouldn't do the Jove part. That was the part I did first. And I had to modify some things to make them fit in my car. So there were far more pieces to assemble when I got out to the site than there would have been. But and Bill Borgatus tried to warn me away from that. But yeah, I did. So.
Well, another aspect of this program is that you can do it in the daytime, at least a lot of it.
Yeah.
So that and cloudy daytime. So that's nice. Especially if you're at an event such as a star party around the country, or a club party, and there's not much going on. Well, there you go. And the club I belong to, we have a guy who loves to do this, and he sets it up at our annual picnic. So he's there with it, and we can all see what's going on, even though it's 5 o'clock in the afternoon. That's always nice. Any other comments here? Okay, then. Well, I want to thank Steve for taking his time, for putting together the program, and for presenting it today. It's Steve has been doing this for, I won't say a number of years, but a few years. So he's had some experience under his belt, and he's been very nice at sharing his knowledge with about astronomy with people, including this aspect of the hobby. The Astronomical League has roughly, I will say, more than 70 observing programs. Most of these programs deal with various aspects of the celestial sphere at night, such as various star clusters and nebula and galaxies and so on. And it has a few programs which really don't have a lot of active observing as you would normally think it. And one of these is the radio astronomy program, but it is observing. It certainly is observing, but it's not through your normal telescope. So there's a lot out there in amateur astronomy to interest just about anybody. You know, if you're a hands-on type person and like electronics, this is something you ought to jump into. And there may be more developments of this coming up, because this program's what, 6 years old or so now. Well, so, certainly as technology advances, perhaps that can be even more. With that, I'm going to bid you all farewell. And again, thank you, Steve, for doing this. Maynard for joining us. This will be posted on YouTube and on the League's Facebook page. So please tune in at a later time and watch us again as many times as you want.
I will point out the radio astronomy program is the only Astronomical League program that doesn't involve the visible spectrum. Roy G. Biv.
Well, okay. Well, maybe we'll have to rectify that and include some other type of weird part of the spectrum with this infrared. I don't know. We'll have to see. But anyway, thank you all for joining us, for tuning into this, and thank you to our presenter, and thank you, Mayor, for tuning in. We'll see you all later. Thank you.
Bye, everybody.
Adios.